afternoon, everyone. My name is Lindsay Moore. With Professor Daniela, we are ongoing research on human activity impacts soil biodiversity. My topic is soil biodiversity difference between the anthropic and natural environments. I would like to introduce some results of soil biodiversity of Abalella project today. This is the outline of the presentation, including 4 parts. Now let's begin. The rapidly increasing human populations and the increasing ecological footprint per capita are placing further pressures on the natural land. In this study, our goals were to identify the differences in soil biodiversity of natural and anthropogenic systems in order to quantify the possible impacts. For this reason, 2 main research objectives were addressed. Firstly, to compare the diversity and community composition of soil biota in anthropic ecosystems with those of relatively natural ecosystems. Secondly, to check how below-ground biodiversity and abundance respond to different lengths and management. We studied soil biota in these 2 nearby spots on the Adriatic Sea coast of the Veneto regions, in both the natural conserved and the anthropized sites, which had been turned into a small vacation islands. The islands just separated by a stretch of sea, featuring the same climate and potential vegetation. In this investigation, we focus on a full set of vegetational stage in both sides, from the beach to the forest. Besides, there were 2 special sites on each island's vegetational type. Totally 10 study plots were established in pairs in Abalella and Calelli. The results show that the dominant bacterial phyla in all soil samples were proteobacteria and acetobacteria, and Phacomyces. The assemblage composition of soil bacteria differs significantly across Abalella and Calelli. With respect to the bacterial communities, both the diversity and richness indices significantly differed between Abalella and Calelli. The highest diversity and richness were observed in Abalella, in the new plantation of trees and the flower bed. We suggest that management techniques to affect the diversity and community structure of the soil microbial communities by changing the soil biotic and abiotic factors. The fungi OTU collected from all soil samples were primarily classified into 6 phyla. Ascomycota and Basidiomycota were the most dominant phyla across all soil samples. The assemblage composition of soil fungi differs significantly across Abalella and Calelli. If you look at this, the right figures, the gradient from the sea towards the mainland is evident both for Calelli and Abalella from right to left on the axis 1. The axis 2 contrasts the samples in the West Salty and particular Calelli soils from all the others. For the fungal populations, the diversity and richness indices grew with the increasing complexity of ecosystems, from the beach to the dune, to follow in the sharp areas and ending in the multi-level forest. Combined with the results of community composition, fungi were confirmed to be organisms less sensitive to osmolarity stress from brackish waters and more reactive to the change of plants. As for arthropods, Alkali and Columbola were the major taxa. The composition differed not significantly across 2 systems. This slide shows the chain of multiple arthropod biodiversity indices, which depend on the complexity of the ecosystems. To sum up, comparing equivalent environments from the vegetational point of view, on average, the biodiversity indices are higher in the enterprise environment. According to the results, trace of human activity to soil biodiversity was not as obvious as we had previously thought. We can observe that human activity still provides some special niches for soil organisms. It is foreseeable that our planet will face the pressure of population growth and continued soil depletion. The key to turning these pressures into positive effects may be hidden in the appropriate management of soil biodiversity. Although the robustness of these findings awaits future experimental testing, they still had improved our understanding of how human activities alter soil biodiversity. That's all for my presentation today. Thank you.
Thank you, Lindsay.